Traditionally, there were only two ways of representing a string within JavaScript. You could use single quotes or you could use double quotes. In modern JavaScript, there is a third way known as JavaScript template literals. And this is done by using backticks, and the special thing about them is that you can add any JavaScript expression as a part of your string by escaping into the expression mode by using the $sign followed by curly brackets. For example, we can bring in a local variable called JSStringLiteral, which in our case is pointing to the string whatever, or we can even use any other value like the number 3.14. There is of course more to JavaScript template literals, but all that you need to know for this lesson on TypeScript template literal types is that they start with backticks, and within the $curly brackets, you can use any JavaScript value. Now let's talk about TypeScript. Of course, there are a number of types within TypeScript to represent various JavaScript runtime values. For example, here we have the type annotation called string, which will accept literally any string that you can throw at it. But in addition to general types like string and number, TypeScript also supports what are known as literal types. For example, you can put the literal type called the string hello, and now the only string that this particular variable will accept is the string hello. Anything else will result in a compile time error. And that brings us to the latest feature of TypeScript, which is template literal types. Here we have a template literal type where we are saying that it must be a string that contains the prefix example : space followed by any other string value. This means that something like example hello will be perfectly fine, example world will be perfectly fine, but anything else that does not start with example will result in a compile time error. Now, just like in a JavaScript template literal, you can put any JavaScript value, you can put any TypeScript type within the TypeScript template literal. Here we are using the type string. So in this particular code demo, you are essentially using the TypeScript template literal to ensure that all strings assigned to this particular variable start with the example prefix. But that's not particularly useful, so let's jump into some real-world use cases for this particular feature. Now, it's common for CSS values to be represented by either a number, in which case it is implied that it's a pixel value, or alternatively with a full string that contains the number followed by the unit of the number, which let's just assume can be px or m or rems. And just as a demo, here's a function that accepts a CSS value. We check if the input is a number, and if it is, we append px, otherwise we use the value as is, trusting the user to have provided a valid unit. However, this trust is something that can be broken quite easily. The user can easily pass in a number or a px or an m, or fudge it up and pass an ex. And it would be great if we could catch it at compile time. Essentially, what this comment for string is saying is that it must be something that starts off with a number and ends with either a px or an m or a rem. And this is something that we can represent quite easily with template literal types. And with that, any misusages are easily caught at compile time. Now let's look at another example. Here we have a function called applyStyle that expects the style to be passed in as a string combination of some size, which can either be small, medium, or large, along with some color, which can either be primary or secondary. This means that something like small primary will be fine, large secondary will be fine, but if we mistype medium in medium primary, we want a compile time error. Now we can do that quite easily with template literal types. First, we define the type union for the size and the color. For size, it is small, medium, large. For color, it is primary and secondary. And now our desired input style string is simply a combination of any of the size literal values, followed by a hyphen, followed by any of the color literal values. And now if we annotate the applyStyle style parameter to be this particular type, TypeScript correctly catches the typo in the medium primary string. Now, one final thing to point out is that TypeScript has seen that size can be 3 possible string values, color can be 2 possible string values, so the style type can only be the 6 possible combinations of these two types, which you can see by hovering over the style type.